What's up, Easy Fam? Welcome back to the channel. Welcome back to another video on ASCP vlogs. Still, if you're just tuning in for the first time, you're highly welcome to my channel. Please do well to like, comment, subscribe, turn on your post notifications so that you're notified when next I make a post. And yeah, one more thing, if you're just tuning into my channel, this is your first video here, I welcome you. A round of applause for the newcomers, but you would want to go through my ASCP prep guide, the playlist. So I took my time to create a playlist that contains everything you need to know while preparing for the ASCP exam. And when I mean preparation, I mean the earlier phase, from account creations to the things you should avoid, the way you should read and all of that. I made about 12 videos and included all of them in this playlist titled ASCP prep guide or thereabout. So you can find it in my playlist section and just go through it, watch each and every video in that playlist, and you are good to go if you have the intention of sitting for the exam. And without further ado, let's get into the content of today. So like I said in my previous video, I said we were going to start a Q&A for those that are preparing for the exam currently, and I would be taking some few questions out of the BOC and also out of my personal experience while reading. These questions are channeled towards ASCP, and they are channeled towards the way the exam questions come out. So if you are going through these questions along with me, please let me see your scores down in the comment section. Let me see your answers down in the comment section as well. We all would just come together and make this work. All this is just to make sure that at the end of the day we all get certified. And without saying too much, if you're ready, let's go. So today, guys, we'll be answering questions on microbiology. So subsequent videos will be on other courses or other subjects, but today's video is solely microbiology. So question number 1 says, proper media for culture of a urethral swab from a man includes sheep blood and phenylethyl alcohol agars, eosine methylene blue and sheep blood agars, thioglycolate broth and chocolate agar, chocolate and modified thiamartin agar. So what do you think is the right answer, guys? I'm going to give maybe a minute or two. Let's make it a minute so that this won't be long. Or maybe seconds. Okay, I think you must have chosen your answer by now. So the answer is D, chocolate and modified thiamartin agar. And why do I say this? Chocolate agar is it's an enriched media, and then they require special nutrients to grow, and these special nutrients are contained in chocolate agar, and the special nutrient contained in chocolate agar are factor 5 and factor 10. That's hemine and then NAD. So if you got that correctly, good luck to you. And remember, they said a urethral swab. So what are we looking for in a urethral swab? That should be Neisseria gonorrhea. So yeah, chocolate agar is the best agar to culture that. So you can find the answer for number 1 in Compendium. You can also find it in Success textbook, and you can also find it in bottom line textbooks. Just look for it under Neisseria gonorrhea, and then you find the correct media to culture it in. The second question, guys, move on to the second question. The second question says, a sheep blood agar plate incubated with 0.001 ml of urine grows 70 colonies of Staphylococcus aureus. How many colony forming units per ml of urine should be reported? And guys, if you know and if you've read up to this part, you'll know that there are 2 types of wire loops that you can use to culture urine, and that's 2 types of wire loops rather. You have the 0.01 and the 0.001. So if you are using the 0.001 that is used to culture urine, how I do it is that I multiply it by 1000, because I'm taking the number of digits that come after the decimal point, and if it is 001, that is 3 digits that come after the decimal point, after the decimal point, right? And then with that, that's like 70 multiplied by 1000, and that would give you 70,000. So the correct answer to this question is D, 70,000. I hope you guys get that. So for this question that I just answered, you can find it in bottom line textbook on page 142. Page 142 in bottom line textbook. So let's move on to the next question. The lowest concentration of antibiotics that inhibits growth of a test organism is the A. Minimum inhibitory concentration, B. Serum inhibitory concentration, C. Minimum bactericidal titer, D. Maximum inhibitory titer. The lowest concentration of antibiotics, guys, not the highest. The lowest concentration of antibiotics. So I would say it is the minimum inhibitory concentration, guys. The minimum inhibitory concentration is the lowest concentration of antibiotics that will inhibit the growth of organisms. So you can find that in bottom line on page 139. That's where you would find that, the explanation to that. So number 4 says, which of the following clean catch urine culture colony counts indicates the patient likely has a urinary tract infection? A. 10 raised to power 1 colony forming unit per mil, B. 10 raised to power 3 CFU per mil, C. 10 raised to power 5 CFU per mil, D. No growth. So guys, what do you think the answer to that question is? The answer to that question is B, 10 raised to power 3 colony forming units per mil. 10 raised to power 3 means 10 times 10 times 10. 10 times 10 is 100, 100 times 10 is 1000. So that is the colony count that indicates a patient likely has a urinary tract infection, and you can find that in Compendium. I forgot to jot down the particular page that you can find it, but you can find it in Compendium. Let's move on to the next question. The steam autoclave method of sterilization: A. Uses 15 Ibs of pressure for 15 minutes, B. Utilizes dry heat for 20 minutes, C. Produces a maximum temperature of 100 degrees Celsius, and D. Requires a source of ethylene oxide. Okay, I believe you must have chosen your answer, so let's move. The answer to this question is 15 Ibs of pressure for 15 minutes. Remember, 15 Ibs, it sterilizes at 121 degrees Celsius, 15 Ibs, 15 pounds per square inch, and you can find this in bottom line on page 137. Page 137. Next question, question number 6. So that's the expected colony counts in a suprapubic urine from a healthy individual is what? The expected colony counts in a suprapubic urine from a healthy individual is what? A. 0, B. 100, C. 1000, D. 100,000. Okay, the answer is A. 0 colony forming units per mil. The urine is not supposed to have bacteria inside. Remember, if you do not have a bacteria infection, if you culture your urine, it will come out as no growth, meaning that there is no bacteria inside. And even when you do microscopy on it, you won't see any bacteria. So, and besides, this is suprapubic. Suprapubic is the most sterile method of collecting urine, because suprapubic is that you're collecting from, how do I stand up? You're collecting from here, guys. Here, the pubic region up here, exactly where your bladder is. Like, you're collecting the urine directly from your bladder, so it's supposed to be the most sterile it can be. So if it has bacterial any form of bacterial growth, then there is a problem, even if it is 100 colony forming units per mil. So the right answer to that question is 0. Next question, guys, number 7. An aspirate of a deep wound was plated on blood agar plates and incubated aerobically and anaerobically. At 24 hours, there was growth on both plates. This indicates that the organism is a what? A. Non-fermenter. B. Obligate anaerobe. C. Aerobe. D. Facultative anaerobe. I believe we must have answered the question by now. Okay, we must have answered the question by now. So if we are taking this bit by bit, an aspirate of a deep wound was plated in blood agar plates and incubated aerobically and anaerobically. Normally, when culture decide an aspirate of a deep wound, from a deep wound, what kind of organisms do we isolate? We isolate anaerobes actually. You get. So there are places, this one you'll find it in bottom line and compendium. There are places in the body that you cannot collect samples to culture for an anaerobe, like your skin or from stool, or you're taking from the mouth. All those areas are not fit for collection, for sample collection when you want to check for an anaerobe. So this time around, it's a deep wound aspiration, which is it's okay for you to collect that and use it to culture for an anaerobe. And then they say it was cultured aerobically and anaerobically, and then there was growth in on the both plates. So this means that the organism is a facultative anaerobe. First of all, when you see these questions, you have to take note of the answer lies in the question. The answer lies in the question. Did you see the way I just thought about it now? I thought about where they said they collected the sample from. They collected it from a deep wound aspirate. And here, my head is telling me, deep wound aspirate, what are we getting from here? We are getting anaerobes. So the answer lies in the question. This is one thing about ASCP. The answers are in the question. It's just about you thinking. It's just you thinking about it. So if you take it bit by bit, you'll find out that the answers are in the questions. First of all, they have given it off because they said it's an aspirate from a deep wound. So nothing, you don't have any business with option C, which says aerobe, or option A that says non-fermenters. So this brings your options down to two, which is obligate anaerobe and then facultative anaerobe. So obligate means that they require only, like, their obligate anaerobes is only under anaerobic conditions that they can grow. When you are obligated to do something, means that by all means you must do it. You get. But then when something is facultative, it means that it can grow under both conditions. So that's why they were able to grow on both blood agar that was cultured and stored and incubated aerobically, and then the one that was incubated anaerobically. I hope that answers the question. And that question goes for number 7. So the right answer for number 7 is D. Number 8. The proper blood to broth ratio for blood culture to reduce the antibacterial effect of serum in adults is what? A. 1:2. B. 1:3. C. 1:10. D. 1:30. I believe we must have answered the question by now. So like I said, the answer lies in the question. The answer is already lying in this question, and that's in the last statement that was made. Said to reduce the antibacterial effect of serum in adults. Adults. So the blood to broth ratio for adults is 1:10. And then normally you collect 2 sets or no more than 3 in 24 hours. So the normal meal per set for adults is 20 meals, because you are collecting 1:10, 1:10, so 10%, that's 20. So that's 20 meals from an adult per set. Then for children is 1:5. So in a set you are collecting 10. So the normal blood to broth ratio for this adult is 1:10, and you can find that on page 248 of Compendium. So you can find that answer on page 248 of Compendium. Let's move on to the next one. The next one, which is number 9, the second to the last, says a penicillin resistant Neisseria gonorrhoeae produces what? A penicillin resistant Neisseria gonorrhoeae produces what? A. Alpha hemolysin, B. Beta lactamase, C. Enterotoxin, D. Coagulase. I believe we must have answered this question now. The correct answer is beta lactamase. Neisseria gonorrhoeae produces beta lactamase, which is an enzyme that breaks down the beta lactam ring, and that's why they are what? Resistant. Even when you use all this penicillin, cephalosporin, and the right and the likes of them, they don't work against Neisseria gonorrhoeae. So an example of bacteria that when you see them, you should test for the presence of beta lactamase. You have Neisseria gonorrhoeae, Haemophilus, Moraxella, and methicillin resistant Staphylococcus aureus. So these three are beta lactamase producing bacteria, meaning that they will break down the beta lactam ring and lead to the ineffective properties of penicillin and cephalosporin. So that's the answer for that, and the answer for that is B. So the last but not the least question, and I read, which selective media is used for the isolation of gram-positive microorganisms? A. Colombian nalidixic acid with 5% sheep blood agar, trypticase soy agar with 5% sheep blood, C. Eosine methylene blue, and D. Modified thiamartin agar. I believe we are done. Yeah. I believe we are done. Yeah, I believe we are done answering this question. So the answer to this question is CNA. CNA is the correct selective medium for growing gram-positive organisms, or gram-positive bacteria rather. So you can find that in Compendium and also page 140 of Bottom Line textbook. And with that, we've come to the end of this practice question for today. I hope with this you've been able to, check yourself and check how much you know about microbiology, how far you've read. Are you prepared? What do you think? Let me know how many, or let me know your scores down in my comment section. Let me see your scores down in the comment section. So don't be ashamed. Even if you get 1 or 2 or 3, it doesn't define you. It just means that you need to put more effort in reading, and then this is more like an eye opener to you, that you need to start reading more into or in depth rather than reading superficially. Again, I would refer you to my video titled ASCP Study Essentials, and that would give you an in-depth understanding of how I read and what books I made use of, because you might just be reading the wrong thing, using one particular book to read different things, and that one particular book might be confusing you. So if you use different books to see the different perspective of things, then you'll be able to understand it more. I hope this video was able to help people preparing for the exam, and also help people stuck in microbiology to see how far they've gone and what else they need to read. And with that, we've come to the end of this video. Do not forget to like, comment, subscribe, turn on your post notifications so that you're notified when next I make a post. This is essential, and I'll see you in my next vlog.